Now we are going to see about the topic algorithmic problem solving. What is algorithmic problem solving? That requires a formulation of algorithm for a solution. We are getting a solution, we are using a formulation of algorithm. The first step for formulating an algorithm, understand the problem, and then we need to decide or analyze what are the methods, what are the computational means and exact situation we are using in an algorithm should be analyzed, and then we need to design an algorithm and need to prove correctness, and then we need to analyze the algorithm and then code the algorithm. If anything has been distracted or error in that prove correctness, then again we need to computational means and we need to analyze and then design and then prove correctness and then analyze. If any of the above steps are not properly processed, then we need to repeat the process from first step. So these are the algorithm design and analysis process. For understanding the problem, following points should be known. It is the process of finding the input of the problem that the algorithm solves. It's very important to specify exactly the set of inputs of algorithm needs to handle. And third point, a correct algorithm is not one that works most of the time, but one that works correctly or legitimate inputs. Ascertaining the capability of computational design. If the instructions are executed one after another, it's called sequential algorithm. Normally, the sequential is nothing but the process being one after the other, choosing between exact approximate problem solving. The next principal decision is to choose between solving problem exactly or solving it approximately. Based on this, algorithm are classified as exact algorithm and approximation algorithm. So, what is meant by exact and approximate? We need to see in the future. Data structures plays a vital role in designing and analysis of algorithm. Some of the algorithm design techniques also depends on structuring data, specifying a problem's instance. Algorithm plus data structure is equal to program. What is meant by program? Combination of algorithm plus data structures. Algorithm design techniques. What are the algorithm design techniques? Design technique is nothing but a general approach to solving a problem or algorithmically that is applicable to a variety of problems from different areas of computing. Learning these techniques is of utmost importance of the following reasons. First, they provide guidance for designing algorithms for new problems. Second, algorithms are cornerstone of computer science. What are the methods of specifying an algorithm? Pseudocode, programming language, and these are the following methods we are using and specifying the algorithm. Pseudocode is a mixture of natural language and a programming language like constants. Pseudocode is usually more precise than natural language, and its usage often yields more sufficient algorithm description. In the early days of computing, the dominant vehicle for specifying algorithm was a flowchart, a method of expressing an algorithm by a collection of connected geometric shapes containing descriptions of the algorithm steps. Programming languages. What is programming languages? Can be fed into electronic computer directly. Instead, it needs to be converted into a computer program written in a particular language. We can look at such a program as yet another way of specifying the algorithm, although it is preferable to consider it as an algorithm's implementation. Once an algorithm has been specified, you have to prove its correctness. That is, you have to prove that the algorithm is the required results for every recommended input in a finite amount of time. A common technique for providing correctness is used to mathematical induction based on algorithms interactions provide a natural sequence of steps needed by such proofs. It might be worth mentioning that although tracing the algorithm's performance for a few specific inputs can be a very worthwhile activity, it cannot prove the algorithm correctness conclusively. But in order to show that an algorithm is incorrect, you need just one instead of its input for which the algorithm fails. Analyzing an algorithm. What are the steps, what are the methods we used for analyzing an algorithm? Efficiency and simplicity is a main theme of analyzing an algorithm. Time efficiency indicating how fast the algorithm runs. Space efficiency indicating how much extra memory is used. These are the efficiency. And simplicity is an algorithm should be precisely defined and investigated with mathematical expression. Simpler algorithms are easier to understand and easier to program. Simpler algorithm usually contains few bugs. Coding an algorithm. What mean by coding an algorithm? Most algorithms are designed to be ultimately implemented as computer program. An algorithm presents both the peril and an opportunity. And working program provides an additional opportunity in allowing a empirical analysis of underlying algorithms. Such an analysis based on timing the program or several inputs and then analyzing the result obtained. And next one, the simple strategies of developing an algorithm: iteration and recursion. What is meant by iteration and recursion? Iteration is a repeating of a process, and recursion is same that of something differ from that iteration. Iteration is when a loop repeatedly executes, controlling a condition becomes false. The iteration is applied to the set of instructions which we want to get repeatedly executed. Iterations include initialization, conditions, execution of statement within loop, and update, increment, decrement the control variable. The sequence of statements is executed until the specified condition is true is called iteration. For loop or while loop. Syntax for loop. For loop start value to end value, do statement, end for. Begin get it, initialize I is equal to 1, for I is less than or equal to n, do print I plus, and end for end. And syntax for while and do while is different. While should be first the condition is checked and then only we need to execute. In do while, first the problems will be executed and then the conditions will be checked. These are the loops and the examples of the looping iterations. Recursion is a function that called by itself is known as a recursion. Recursion is a process by which a function called itself repeatedly until specified condition has been satisfied. So, what is meant by factorial numbers of recursion? What is meant by factorial? Multiplying of up to the numbers. What are the n numbers we are calling? We are multiplying both. If we call n is equal to 5, we are multiplies 1 into 2 into 3 into 4 into 5. That is a factorial of a number 5. We represented it. This is a term methods of factorial of 5.